The technological process of creating drones, also known as UAVs, unmanned aerial vehicles, is a journey that crystallizes multidisciplinary knowledge. From materials science, electronics, mechanics, information technology, to artificial intelligence. To produce a complete modern UAV capable of safely and efficiently performing various tasks, engineers and scientists must follow a strict process consisting of multiple consecutive steps. Starting from the idea, the first research process is to determine the need for using UAVs. Whether the UAV will serve agricultural surveying, urban monitoring, automated delivery, or applications in national defense, all of these will determine the subsequent design factors. Requirements regarding weight, payload, flight time, speed, operating altitude, and the ability to carry sensors or transmission devices will shape the overall configuration of the flying vehicle. After defining the objectives, the design team enters the stage of idea research and technical planning. They will choose the appropriate type of UAV: traditional fixed-wing, multi-rotor, tilt-rotor, or a hybrid between a helicopter and a glider. Each type has its own advantages and disadvantages in terms of maneuverability, flight time, stability, and flexibility in various environments. Next, the development team will proceed with aerodynamic force calculations, simulation, and structural analysis. Specialized 3D design software such as SolidWorks or AutoCAD will help create models, simulate load-bearing capacity, and select suitable materials like carbon fiber, ultra-durable plastic, and lightweight aluminum alloys to ensure the UAV has a sturdy structure with optimal weight. In this step, the aircraft body, support system, wings, rotors, and landing gear are all designed in detail. At the same time, electronic engineers will integrate essential components for the drive system. From the microcontroller unit, MCU, motion sensors, IMU, GPS positioning system, to signal transmission antennas, wireless communication modules such as RF, 3G, 4G, and Wi-Fi. Simultaneously, they will select motors, power source batteries, lithium polymer or lithium ion, and lift and thrust control systems. One of the most complex steps is developing the flight control software, also known as the autopilot. This software must be capable of integrating data from sensors, optimizing control commands, maintaining the UAV's balance during flight, executing complex commands, such as holding position, flying along a predetermined route, automatically avoiding obstacles, or returning to the starting point when the signal is lost. For advanced UAVs, additional artificial intelligence algorithms are included to help recognize and track objects or respond flexibly to changing environments. When the hardware and software have been completed at the prototype level, the manufacturing process begins. Components are machined using CNC, 3D printed, molded, or assembled manually. The electronic system is soldered and installed into the aircraft body. The entire UAV is structurally inspected to ensure there are no manufacturing defects, then connected to a computer for programming and parameter configuration. Next is the testing phase. Initially, the UAV will undergo functional testing of individual parts, checking the motor, sensor response, and data transmission capability. Then, the UAV is tested in simulated or indoor flight conditions under close supervision. Once stable, the UAV moves on to real outdoor tests, testing takeoff and landing capabilities, stable flight, cruising flight, and operation in wind, light rain, or other environmental conditions. Additionally, safety measures are also verified. The ability to automatically land when the battery is low, stop the motor in case of a malfunction, or avoid collisions. The test results will be compiled, analyzed, and evaluated. If errors arise, the development team will adjust the mechanical design, electronic system, or software, then return to the testing loop. This process may be repeated multiple times until the UAV meets technical standards and operates stably. Once the prototype is completed, the next step is mass production. At this stage, the processes will be optimized and more automated to reduce costs, improve quality, and increase production speed. The quality of each product is thoroughly inspected before shipment, especially for UAVs used in military or critical missions, requiring each unit to meet strict standards in every component. Alongside production is the development of an ecosystem supporting UAVs. Ground control stations, monitoring software systems, data management, maintenance services, software updates, supply of spare parts. Finally, the UAV is handed over to the user, accompanied by a user manual, installation training, operation, and maintenance. The technical team will support customers in answering all questions to ensure the UAV operates optimally. Depending on the specific application, the UAV can also be customized with specialized sensors such as thermal cameras, radar, LiDAR, live image transmission systems, spraying devices, or modern scientific measurement modules. Looking back at the entire process, from the idea stage, design, prototype fabrication, testing, mass production to delivery and operational support, each step requires careful investment in expertise, technological innovation, and close coordination among many departments. The continuous development of science and technology is making UAVs increasingly intelligent, compact, durable, and multifunctional like never before. This is the result of rigorous, creative technological processes that transform UAVs from ideas on paper into reliable companions in the skies of the future.